Hello viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about Nissan's e-Power. So let's dive deep into it. So what exactly is the problem that Nissan had to make e-Power? Well, engine has reached quote-unquote peak in 1990s. So basically, if you watch very old movies, as in like 1930s to 1950s, you will find almost all movies and TV shows, they have like dudes working on a vehicle. Why? Well, cars were not reliable. Until Japanese get into it, like cars were like, good luck. Now they are very reliable. But here's the deal. So there is a plateau to it. So by 1990s, if you had bought a vehicle from 1990, it still would be working now. But if you have bought a vehicle in, let's just say, 2010, good luck. So reality is people realized like there was something epic at that time, like sweet spot, like not too much cheapification happened, not too much excess stuff was added to it. So it was just right. And so what we have been doing, right, from an engineer point of view, what we have been doing after 1990s? Well, we have been focusing on two core things. First is emission. We are adding extra stuff with some more stuff to reduce emission. Heck, right now the biggest added stuff is like almost all diesel vehicle has to have a fluid that's supposed to suppress NOx emission. Now, some people are saying that it's not actually a good idea because again, transmission of that extra fluid every place where the engine is going. Yeah, and again, added weight, mass and all that may not be wise, but we have done that. And lot of advancement in fuel computer specifically, so we can basically control fuel so precisely that we can keep the catalytic converter at precise temperature so it does its job far more optimally. So we have done amazing things in terms of emission, meaning if you compare emissions of today's engine versus 1990s, you will see some difference. So that has worked. But here's the deal. Another is efficiency. Now, okay, but mileage did not change that much. Efficiency on low load. That's why we have exhaust gas recirculation now. So basically, once your engine is running at peak power, like the sweet spot, it's really good. It's breathing. It's like, but here's the deal. The moment you go low throttle, let's say you are crawling into traffic, at that point in time, your engine is very ludicrously unhappy. So we literally stuff exhaust gas back into your cylinder just so it does not suffocate and improve efficiency at low RPM. So that's what two major development has happened. Basically, your emission went down and efficiency at lower load, partial loads. Not like the peak load. Peak load was like if you had a vehicle at 1990s, more or less the today's vehicle will give you the same BSFC, as in like BSFC that we achieved. Peak 220 was the peak achieved. I've seen that's the highest report I've seen of like Toyota engine. Today still the same. Heck, some engines are worst is 230. So fundamentally we reached a point, like we have reached a peak point, and this creates a very bad taste in customer mouth simply because customers are getting claims, right? Every vehicle, this vehicle is more efficient, more optimized, more this, more that, and they are never getting the money back, as in like they're buying a car that's supposed to be more efficient and turns out it's not efficient. The fuel consumption is never going down. Like there was a time where it was like 80s to 90s, they were like, whoa, it's consuming less fuel, to now it's like, dude, it's consuming the same or worst. So that creates a serious issue. Now, why is that? Well, it's an engineering problem. It's not that there is an aspect of companies being stupid. Another aspect is company being, planned obsolescence. But there is a scientific reason you can't do that, because you are trying to couple two variables. For example, you take an engine. This is how engine is tested. Do not fall for the numbers of like 30% efficient, 40% efficient. Those numbers are meaningless. Always pay attention to BSFC, brake specific fuel consumption. Meaning when you make an engine, let's say we are working on CV engine. Once we're gonna complete the engine, we're gonna put it on a dyno. Then we're gonna drive it at different RPM, but also at different torque loading. Meaning, let's say 500 RPM, I'm gonna put torque loading of 10 Newton meter onto it on the shaft, and then measure the fuel flow. Do it for like equilibrium time, let's just say 1 hour. Then we go to 20 Newton meter. We keep measuring it. Do it in X and Y axis, as in like a lot of RPMs and a lot of torque values, and then you'll get this graph. So this graph will show you where is the sweet spot, meaning this puppy, as in 225. 225 is the lowest amount of fuel it can consume and still give you 1 unit of electricity, as in 1 kilowatt hour. Now, again, electricity assumes you have 100% conversion efficiency of a generator, but generally we compensate for generator efficiency. So that's what you get. But what happens if you increase the RPM? You start to lose, as in, even though the energy that you're getting is same, the fuel burnt is higher, as in like now you will burn 230. And here's the part that truck drivers are really frustrated by. Truck engines do not like to run on partial system, meaning if you have the same truck, right, 2500 RPM, like, okay, what if there's no load? Like, truck engine would be designed for full load. Let's say 60-ton full load, go YOLO. And you're like, okay, there is no trucks behind me, I'm just idling. Yeah, it will burn fuel, 700. It will burn more fuel because it's idling. It does not like to do that. So fundamentally speaking, you lose efficiency. And again, that's the reason why we have exhaust gas recirculation. You want to soothe the engine in such a way, or do cylinder deactivation. So this is an engine graph. Does not matter who is the manufacturer, does not matter petrol, diesel, gasoline, whatever have you. All engines have this. Of course, the numbers would be different. For example, the best optimum engine that you can buy right now in the market would be around 230 to 220 grams of gasoline fuel per unit of energy. What about diesel? A good diesel engine can start from let's say 190 to let's say 175. A good diesel, like Scania engines, I have seen 180 grams of fuel consumed for 1 unit of electricity. You go really big container ship engine, those puppies are ludicrously efficient, as in 150 grams only for 1 unit of energy production. But again, that's why the RPM is so slow and the stroke to bore ratio is so stupendously high. It's like diameter 1 meter, travel 2.5 meter. So of course they will be efficient. But here's the deal. So why can't your gearbox keep your engine here? Well, it's a gearbox. It can't. How many gears you gonna have? If you have CVT will burn most of the energy in frictional heat. And if you had basically normal sequential gearbox, this will be your engine map. So realistically, you never get the mileage that you're supposed to get. Like right now, any engine you have, whatever manufacturer, whatever brand, it is really efficient. It's just that it's coupled to a thing that is not efficient. So it's like, I'm doing my best. Fuel competitor is like, bro, I'm trying my best. You're pressing the accelerator, road is going up, my torque loading is going here. I'm trying to match the RPM, but it's like, no, it will overspeed. So you have to burn it more, stay at inefficient point or worst. So it's an engineering problem. So you have an engine that wants to be at one point and your wheels that want to be at different point. Coupling them with a gearbox does not work. This happens when you do that. And don't be shocked if you do this to your fuel computer and your like mileage is like lol. So this is a fundamental problem. That's why locomotives and diesel submarines have solved this long ago, like a century long ago. So now let's look into Nissan's offering e-Power. Now be mindful, it's a really horrible name because e-Power is, they already had this name. This is generation 3. So blame Nissan, not me. So Nissan have a complete portfolio. They have ICE engines, as in like naked ICE engine. They have hybrid, which they have like series parallel and all that jazz. And they have electric vehicle, full electric vehicle. So they do have good portfolio, as in like they have sold enough of it that they know people are angry with the fuel consumption. And not to mention, as inflation is getting worse, as we are getting poorer, and as fuel prices are going higher, that sting is no longer like, it's like, So that's why they are realizing series hybrid. If you have watched my channel for any amount of time, I've been always talking about that series hybrid. So let that be very clear. The hybrid started to reach into market very long ago, as in like 1993, Toyota dropped it, Honda dropped it, if I'm not mistaken, 1998, Ford also dropped it after, but they always had this BS, which we call transaxle. So the idea is you have 2 motor generator unit and 1 planetary, or sometimes even 2 planetary. So idea is, this always gives orgasm to marketing people, where they are like, hey, what if we combine the power of all 3? What if your engine is going all out? What if the motor generator unit is going all out? And what if we dump that power into the wheel? What if that second motor generator unit is also doing that? It's like, yeah, that's why this never became the normal mainstream, because of the planetary gearbox and that itch. It's like, what if we dump all the power in the wheel and like you have a cheap car that behaves like a Ferrari? It's like, that is not how you're supposed to do it. So that's why this, even though this has been done so long ago, be mindful. I do not blame Toyota or Honda for not pursuing this to this level, simply because when they started in 1990s, they were using nickel cadmium batteries. Battery voltages were too low, like as low as 72 volts. Some designs were like 200 volt. That was not enough. And there was biggest penalty they had is that electric air compressor were not a sorted thing. Right now you can pick up a phone, yo man, I need electric air compressor, like at least 20-30 OEMs will be like, bro, look at our catalog and buy whatever you want, whatever voltage you want. Heck, you can get electric air compressor that can work as low voltage as 48, although amps would be stupid high, but it can be done. And for all the electric vehicles, it's like 400, 800. I have seen the stupidest one is 1500 volt. I'm like, damn. And be mindful, that has like cascading benefit to customers, simply because if you went to any car shop almost all car servicing shop has refrigerant refilling. Why? Well, your household refrigerator, your air conditioner, they have hermetically sealed system. So unless there is a crack or something significant, like something happens, it will not leak gas for decades. Compare that to your car, it has a shaft going through the hermetic seal chamber. So, and again, that's why it has to be tight. But again, if you make it too tight, it will take too much horsepower to spin it and it will burn out. And if you reduce the tightness, it will leak gas too quickly. So that problem is now solved, meaning now if they are like, hey, we want a battery box to drive the air compressor, they're like, yeah, sir, we have this option. Everything in your car can be done on electric, meaning your car is 100% electric. That is doable, meaning now you can float the engine. Now this reduces weight multiple ways. First, you can throw away the transmission. That's a heavy puppy. You throw that away. Does not matter whether it's a planetary automatic, does not matter whether it's a manual 6-speed. You throw that away, that saves a lot of weight. Second, you throw away the variable valve timing system, because again, it's a generator. It's supposed to go at 1 RPM, it's supposed to stay at that RPM. Exhaust recirculation systems. A lot of things you can just like throw it away. So your engine becomes lighter, more optimum. Power to weight ratio improves. And then you just run a generator. Generator powers the battery powers your motor. And again, development of the motor, you know, like right now, if you want the most oomph, electric motor is there. Even compared to this, electric motor will outperform it as long as it's big enough rotor. So that's what they did. It's like, hey, and I'm pretty sure the design literally looks like a transaxle from some other manufacturer. So I'm pretty sure one of the same OEMs is designing the system. So they are like, you know, using common parts. And again, you should do that if that will reduce the cost. So from 2026 models, as in be mindful, it's available right now in the market, but they are calling it like 2026 model, V3 e-power systems is 100% electric drive, meaning it's an electric vehicle first, which again, you can't charge it. The idea is they wanted to battery be very small and they did not want to add the cost of onboard charger. So how does this work? Well, this is an electric vehicle you charge on the road. That's it. Now benefit, we'll talk about that. So you have engine creates the generator charges the battery runs the inverter runs the motor, the end. And be mindful, all the auxiliary system also, like your steering pump and anti-lock braking system pumps and wiper pumps, everything else, including air conditioner was the biggest load that was like hard to translate, but we have done that. So it's a complete, right now what you will buy, it's a complete EV with just have a tiny battery, nothing more than that. So this is a e-power version 3. So what did the company gain? Well, company gained much smoother and quieter ride. Here's the deal. When you are young, you watch Fast and Furious like, yeah, you're gonna do that. As you get older, you're like, yeah, ain't nobody got time for that. Ain't nobody got time for that. And again, I've seen that in Indian youth. So uniquely, it was like, you know, we always like, we want bike, no, scooty is for girls. We do not want to drive scooty because scooty has poor efficiency, as in like CVT, very poor efficiency, but it's very easy to drive. Over years, I've seen every guy is like, in the young, bike, and as they get older, it's like, bro, just give me a scooty. So they're like, hey, what if we give you a car that is easy? What is the easiest vehicle topology? Electric vehicle. You do not have to worry about it. So it's smooth, that customers want, and it's quiet. Why it's quiet? Because it's not physically connected to anything. The engine is physically floating. So they're good. They got this. And what about fuel consumption? They have reduced it by 35%. They are claiming 40. 35 people have got in real world road. Although let that be very clear. I'm pretty sure if you run AC, they are doing in European environments, of course. AC is not going YOLO. In India, it will go YOLO. So I do expect the fuel savings to be a bit lower. But again, even your petrol vehicle will burn a fuel at that point in time. So you get snappy performance of a full electric vehicle, meaning you press the accelerator, your car just go wham, and it does not have that big ass battery weighing it down. So it is actually super fast. And yes, engines are very light nowadays. Like surprisingly lightweight engines are available for your vehicle. So that is there. And battery is small. How small? 2 kilowatt hour. And like, wait a minute, that's small. Yeah, that is small battery. To give you a context, the oldest electric vehicle I remember is from like a Evo vehicle or something. They also started with 15 unit, and then they got to 30. I think Tesla started with 30, 33 units, and now everybody's going stupid. They're like 90 unit, 120 unit, 200 unit. I'm like, what the hell are you smoking? So battery is small, that means they can keep it in the same price envelope as the normal vehicle. So what is the price envelope? 15% surcharge, which again, not that big, and you can even have that 15% extra cost recovered to you in few years by the fuel savings. And not to mention quality experience. People willingly pay for things if they do not have bad experience, good experience. And this is their graph. Again, that's why I say always understand BSFC. This is what they're showing: engine RPM and engine torque. Of course, they did not show the BSFC numbers here, but this is what they're showing. So this is your normal naked engine where you are like your fuel computer is doing its best, but it's trying to it's like trying to keep it here, but can't. Most time it's here, low RPM crawling. And your series parallel hybrid system, they do have the advantage where the motor generator unit acts as a buffer, as in, like, let's just say you are rolling downhill, your engine RPM is at the sweet spot, but the torque loading is low. The motor generator unit number one will be like, okay, I'm going to leach energy from it, so the torque loading goes to the sweet spot. It can leach energy. And what if you are like going up a hill, so torque goes up? It's like, oh no, we'll not keep the torque at the sweet spot, and then extra torque required would be driven from the motor unit. So it does improve the situation, but again, it's still sloppy. As a generator, it does not matter. There is nothing like no idling, no operation, low end torque not necessary, down speeding, nothing. It's just like go here, stay here, the end. It's just the ends everything. So that's why you can get so much mileage, even though you have so much conversion inefficiencies because of this. So that's why even with adding throwing away transmission, that mechanical coupling, you're throwing that away, you still save fuel while getting quality experience, while getting much more smoother experience, especially in traffic. It's like, ooh. So, and people are getting that in real world. That's what's the funny part is like. And here's the shocking part to me. I have a very lightweight car. It's a Maruti Espresso, very lightweight car. It's like half of the weight of this, and horsepower is like 1/3 of this. And both of the vehicle have the same fuel consumption. I'm like, that's not fair. Although this is another aspect of it. Like many times people who are buying their first high-end vehicle and they are shocked by the brutal fuel consumption, this can actually tame it down. It's like, yo, not that bad. So understand that. Like I have a vehicle that's half the weight and third the power, and it consumes the same fuel as this behemoth, comparatively speaking. This is a full SUV. Mine looks like a SUV. So that's like shut up, take money. That's why they are doing it. So what is the scope of this? Well, here's the over time, this is V3 technology we are talking about. I'm pretty sure in V4 they're gonna make it the battery bit bigger, and all they have to do is add onboard charger and DC bus. DC bus may not be necessary. DC bus, as in like whenever you talk about charger, there are two types of charging of electric vehicle. First is AC charging, which is AC level 1 and AC level 2, which simply means you have a box like this. This is a circuit breaker with a screamer that screams, do not drain more than this amp from me. Or like, in this scenario, to like, do not drain, let's just say 10 kilowatt. If you drain more than 10 kilowatt, I will disconnect. That's the only thing that microcontroller there screams. 10 kilowatt or lower, do not go higher. And that's the only thing it checks. So how does you control it? Well, it's the onboard charger that is in your vehicle controls it. Like, and if you're buying electric vehicle, many times you get that option, as in like how powerful your onboard charger has to, because again, it's an expensive device. So if you are like, you do not pay attention to it, you'll only get 7 kilowatt. If you pay attention to it and you're like, I want to have high power, you can get, I think, highest 22 kilowatt hour. 22 kilowatt as in like a power capacity rating. So at that point, you can charge in like 2-3 hours only. So that is available. And DC bus is that 200 kilo. Basically, whenever you are hearing kilowatts, they are talking about converter being outside of the car. So there you have that big ass unit, which are super expensive and stupid. I'm not joking, they're so expensive, you would be shocked. And not to mention, it requires a high voltage transmission line, a big ass transformer to feed it. 200 kilowatt, that's like a transformer that feeds a small neighborhood. Saying that 200 kilowatt for one vehicle, it's like, yeesh. So you can do that if you have DC bus, that two small plug below that circular plug, that's a DC bus, and good onboard charger. So nothing too fancy, nothing to like, they can make it, they can sell it, fine tune it, and then they can just make the battery bigger, onboard charger bigger. And here's the deal. Electric vehicles were not successful. They are still not successful. Why? Our population planet-wide is going down. Birth rate is planet-wide down, as in 150 down. 150 countries, there are almost 200 countries, and 150 countries are below 2.1. So population is not exploding. It's not growing. But our oil consumption is. And either electric vehicles are drinking oil or their electric vehicles are not selling. Here's the deal. Now, since I'm working with engine company, our CA had to do a job where it's like, okay, we were talking about two-wheelers. So it's like, okay, sales record of all companies. Let me tell you, the sale records like opened my eyes, like, oh, so many electric vehicles. It's nothing. It's nothing. And be mindful, that's the same story in China, same story in India, same story in America. And again, you can find some tiny European nations, but again, compare from top 10 populated country of the earth, outcome is the same. Nobody's buying electric, realistically. And that's why our fuel consumption is going. Even the people are not growing. Why the heck your fuel consumption is going up? Because we did not do this. This technology saves us all today. We just jumped away on Elon Musk bandwagon. So, because again, if you have this plug-in electric vehicle, everybody can buy it. Right now, people do not want to buy because half of the people will say, oh, it's too expensive, which it is. Other half will say, oh, it does not have enough range, which here's the deal. This graph is the actual reality of humanity, meaning pick a lane, okay? Any lane. You get the data from Google, you get the data from Apple, you get the data from transportation industry sectors, or get the data from your federal transportation agencies. Outcome is the same. Most people do not drive like, I need 100-kilometer range, I need 10,000-kilometer range. You do not. Okay, this range damage, brain damage is just that, brain damage. What you're supposed to do, like how you charge your mobile phone, you charge at night, the end, go home. If most of the people are generally here, basically the percentage of driving that happens less than 50 kilometer is the majority. This is where humanity is burning the fuel. But because we are targeting these people who are like, okay, I drive like, that long drive, but here's the deal, that happens rarely. For example, can I survive on an electric vehicle? No. Simply because most of the time, even though I'm driving less than 10 kilometer, I do not have two vehicle money. So I'm going to have one vehicle. It has to be a petrol vehicle because it's cheaper. And most of the time it's 10 kilometer, but again, when I have to go for my court case, that's 220 kilometer one way, and the next place is 250 kilometers. So 500-kilometer travel in one day, that's not happening on electric. And yes, even if electrical vehicle in India says that rating, it's not real because it's done without air conditioning. India is hot, we need air conditioning, and that consumes more power than the traction motor, simply because your car is a greenhouse on wheels. It's hot. So because everybody is trying to satiate this part, it's not working. If you had plug-in electric vehicle, everybody can buy it. Nobody would have a reason to not buy it. For example, what this Nissan did is like, hey, buy this car. It's like, oh, why is hybrid? No, it's a petrol car. It just consumes less fuel. The end. It's just smoother. It's quieter. The end. But I do not drive so much, no problem. Charge it every night. Of course, I'm not talking about V3, I'm talking about V4, when they can add, system. So most of the time, majority of fuel consumption is here. That will be kaput, done. And this also solves the, where do you put charging infrastructure? People will follow. It's like, hey, I can stop here to charge it. It would be nice to have charging here. Then people will follow, rather than government, we're gonna burn $1 billion to create charging infrastructure. No. Create this plug-in hybrid vehicle so everybody uses it, and over time people will say, hey, lot of people are with plug-in hybrid are going here, what if we put charging there? Now we make money, self-sustaining. So 100-kilometer or more driving, that's why electric vehicles are not becoming. And not to mention, if I remove subsidy, nobody will buy electric. So fundamentally, you will have a very fuel-efficient internal combustion engine. You will reduce CO2 emission today. You will reduce emissions also. NOx emission, carbon monoxide emission, all of those will go down. And you will save money today. That's the most important part. Everybody will willingly do it. That's why you will not have the country fuel consumption going up continuously. So there is a lot of scope. Nissan is doing something very clever, not groundbreaking, clever. It's like, hey, let's do this. Let's take care of everybody. Not just people, I need 10,000-kilometer range. Shut up. Buy this. It's like, but what if I have to drive for very long? It's a combustion vehicle. How you used to be doing it for last 1 century. Shut up, do it. Once we have better technology, once we have better battery, of course, we'll keep increasing the battery. But until then, save the planet for today. So we have a better tomorrow. And if you cook the planet today, there is no tomorrow. So what can we expect in the future? Well, EV subsidies are already starting to wear out, be it in USA, be it in China, be it in India. And we have been burning billions. I was shocked. I thought maybe 1 billion. Heck, 1 billion Indian government did and central government did only in 3 years. And be mindful, other state governments have also done a lot of money. So we are burning money like there is no tomorrow. And same goes with China. China did new energy vehicle system. And even they are like, yeah, we can't keep doing this. It's and if you have seen a lot of graveyards of electric vehicle in China, that's the reason. The moment subsidy starts to wear off, they're like, yeah, nobody actually buys it. Because again, it's not buy and forget vehicle. People want to buy and forget vehicle. It's not there yet. And let's not even talk about fire hazards. So fundamentally, you can see that in BYD. a subsidy happens, BYD comes in out of nowhere, every vehicle is electric vehicle, subsidy starts to go away, hybrid vehicles. Yeah, that's the reality of it. And we can do even better. Nowadays, more and more cars are coming with turbo. Here's the deal. Turbo compounding can be done, meaning you can have a third motor generator unit that is behaving like a motor generator unit, like a F1 system. And how much energy you can recover? Well, you can have 5% to 10%. The Porsche did that. I have linked the video down below. This is from Porsche. They are giving you 5%. Now, isn't that too little? Yes. It's little simply because Porsche is making a super kind of deal, so they have two small turbo. If they had like ship where they had one big turbo, then it would have been more efficient. Like Edison can do that. Like once they have sorted everything on, then they can have like, because they have engine, like a whole space volume needed for a big turbo, they can have that big turbo. And they can get power without the fuel drain. And again, if your traction motors are running on electricity, your battery is the primary energy storage, that electrical energy is actually useful. So instead of running your generator for 2 hours to charge your battery, you can only run it for 1 hour, 40 minutes, 20 minutes of fuel saving. So that is doable. So Edison Motor is from Canada. They are doing it. Thomas EV, he's from India. I also done a live stream with him. He's also doing the similar thing in India. And then Nissan is from Japan. So a lot of companies are realizing this, like this hype of like, burn billions and billions of dollars on this and that, and like use plug-in electric vehicle. Everybody can do it. Everybody can save money. Everybody can save the environment today. Not just like, what if we had like $10,000 trillion of inflation adjusted, subsidies? So like, that's not logical. If you have to give that much subsidy for that long, it's not logical. So this is the true next level technology. I'm very happy that companies are coming down to reality. And be mindful, that's why there is no electric truck, even though Elon Musk has been smoking from 2016. We have electric trucks that are more efficient than rail. I'm like, bro, I know you can sell any damn thing to any stupid people. Why there's like Elon fans are so stupid? It's like he compared it against rail and people were like, yay. I'm like, do you understand metal on metal rolling resistance? Like this guy will have oh, by the way, that's why he was making his truck company. He got pissed off by Elon Musk. It's like, I ordered the truck. Where is the truck? No truck. I make my own truck. And Thomas also solving one of the issue. Our trucks are like generally upwards of 60 ton. Here's the deal. What happens when it's not 60 ton? Once like you drain the load, what then? Yeah, it burns too much fuel. Again, PSFC goes down. You burn too much fuel proportionately. It's like, okay, turn off the engine, run on battery, the end, go home. And when the engine turns on, it does not even require like, a lot of diesel particulate filter. Why? Because he warms up the engine on battery power, as in like engine spools up for 5 minutes, then he injects the fuel. So you do not have that smog output. There's like a lot of amazing things. Like realistically, we can do that so we can have it tomorrow, so we can solve that problem. And be mindful, this technology allows you to like, hey, we have a battery. Let's just say you start battery with small puppies, 100 unit battery, 200 unit battery, for trucks I'm talking about. And then you can keep increasing as better technology comes in. If you directly go to electric, it's not happening. That's why 2016 Elon Musk weed. So future is very exciting. I'm finally happy that more and more people are waking up to reality. It's like, yeah, you can't just say like, oh, there is this one tiny European nation. It's like, dude, that population is tiny. Compare that to top 10 population, top 10 at least. Top 1 is China, India, and USA. That are 3. So fundamentally speaking, we have to wake up, so to say. We have to save the planet today. And this technology is really good for that. Series hybrid. Plug-in hybrid will take care of all of us today, so we can fight for tomorrow. So this was my presentation on basically new, amazing, exciting technology from Nissan e-Power version 3. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me accomplishment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.